Welcome to Spring LIB.
Part A, kinetic energy can be written as K is equal to mc square into gamma minus 1. Gamma we know is equal to 1 minus beta square minus 1 over 2 We can expand this 1 minus beta square or whole 1 minus 2 using a binomial theorem, and once we do expansion, our term becomes 1 plus minus 1 over 2 into minus beta square, this is our second term, and then plus 1 over 2 into minus 1 over 2 into minus 1 over 2 minus, this is not 1, this is 2, sorry, into, so I will close this, minus 1. So I have two brackets here. This closes this one, minus 1 over 2, and this closes the whole, and then multiplied with minus beta square whole square. So the gamma expands into a binomial theorem, and this gives me all these terms. Now we can write kinetic energy in terms of those terms by just substituting these values back in the original formula, this one. So we'll substitute the gamma here. Once we substitute the gamma, then the 1, minus 1 and 1 will cancel out. So we are left with approximately 1 over 2 mc square beta square, this is beta square, and then we add this with this term 3 over 8 mc square, and then of course this beta 4, so the beta 4, In part B, if we substitute the beta value to be 1 over 20 and mc square for electron, what is the classical energy? So the classical energy can be written as classical kinetic energy K. So I will write Kc, classical, is simply 1 over 2 mv square, which is equal to 1 over 2 mc square beta square. So we can look for the mc square for electron, and the value we have for mc square electron, so I will write, we will use this later also, so I will write it separately. Mc square for electron is 8.19 times 10 to the power minus 14 joules. So electron rest mass energy is 8.19 10 to the power minus 14 joules. If I plug this value here and plug the value of a beta, which is 1 over 20, then the classical kinetic energy I get for electron is 1.0 times 10 to the power minus 16 joules. This is the classical kinetic energy. Now the first order kinetic energy will be, so the first order kinetic energy, I will write FO for first order, which is equal to, as we can see here, the first order kinetic energy is 3 over 8 mc square beta 4. So our 3 over 8 mc square beta 4. So mc square, we already have a value mc square, which is 8.19. We can substitute this value here and then multiply with the beta. So the beta is already 1/20. So once we substitute these values and do the maths, then the answer we get for first order kinetic energy is 1.9 times 10 to the power minus 19 joules. 19 joules. Part D, so we have a part D. In this case, if we have a beta which is equal to 4/5, then our classical kinetic energy, classical I will write Kc, which is equal to 1/2 mc square beta square. So the new beta is 4/5. We will plug this value here and take it square. mc square, we already got the value, which is 8.19 10 to the power minus 14. If we plug those values and do the maths, then we have the answer is 2.6 times 10 to the power minus 14 joules. Minus 14 joules for this case. Part E, what is the first order kinetic energy? So the first order kinetic energy for this case is FO. First order kinetic energy can be written as 3/8 mc square the beta 4. Then as usual, we will substitute the values instead of square here, so we have 4. There's nothing new. And then we will write first order kinetic energy, which is sorry about this, this is not 9, this is 3. So then 1.3 times 10 to the power minus 14 joules. Minus 14 joules. Part F, what is a beta? So the beta will be for if the first 3/8 mc square, the first order, is equal to 4, is equal to 1/10 of 1/2 mc square and beta square. Then we will just cancel out terms on both sides. mc square will cancel out, 1 beta square and then 1 beta square cancel out. So we are left with a beta value, which will be simply 0.37. End of the problem. Thank you for watching.